Hey, welcome back to ZK Master Tech. Today, we've got a wounded soldier here from the harvest this season. We're about a couple weeks into harvest, and then we're hitting it pretty hard. Haven't had a whole lot of time to video because I've been just scrambling to try to get combines ready to go to the field, and then we had combines ready to go to the field and break down, so we're just running 100 mile an hour right now. But one of my really good customers, he's got a 780 here, and he broke a couple swing arms on the sieve frame. Did a little bit of damage, and I'm going to show you what all happened, so let's get into it. All right, so we gave the combine a hysterectomy here. This is what it looks like with no chaffer and sieve frame in the machine. We've got the elements out. We got some stuff out here on the concrete pad. I pull the return pan. We got the chopper, the power cast tailboard off. Over here, we've got the chaffer and sieve frame sitting on the stands. Me and Josh did all this in about 5 hours yesterday. So what happened was there's a swing arm right here for our sieve frame. This is the rear swing arm for the sieve frame. It snapped that bolt there in the frame, and it snapped off this bolt right here. That goes to your pitman arm. That's what's making the arm swing and making the frame go back and forth. And we got some boo-boos in the side sheet we're gonna have to fix and make that look like new, so I have to do a little fabricating there. And our chaffer frame seems to be in good condition. The only thing I'm going to replace are these black pieces here on the side. So this is the new style chaffer frame. The reason why I pulled the return pan to get this thing out is because these fins up here don't want to clear the return pan very well. You can get it out without taking the return pan out, but it's a whole lot easier if you take the return pan out to get this chaffer frame out, because now you got these big cast pieces here on the frame, and this piece right here will dig into the sieve frame seals awful hard when you're trying to remove it, and a lot of times it likes to break those. So the only thing we're going to replace on the chaffer frame are these pieces here. It rubbed in pretty hard, so not too bad there. Sieve frame, on the other hand, she's going to get new side sheets. Got a lot of damage right here. And this front piece, we found this in the clean grain auger. It just fell off. Looked like all the bolts came out, and except for that one, and it just ripped out. This piece fell off. So that's nice. Of course, we, ripped the seal pretty bad. This bolt got loose. This is where we're rubbing the side sheet on the rivets here. Ripped this seal completely off, and then about rubbed the rivets off here, and rubbed into here pretty hard. So sieve frame's gonna get side sheets, and we're gonna recondition the sieve frame, and then we're gonna fix the inside sheets of the combine. And I'm gonna have to get in there and vac out all the crop debris so we don't start a fire when we're welding inside the machine. So let's get after it. Josh is welding up some gouges in the steel on the side sheet, grinding them smooth. That looks a lot better, Josh. But that hole's a little worse.
So we got that guy up there.
Yeah. Yeah, she's got some ouchies, Josh.
Yeah.
And that bolt broke right there. That swing arm did some damage in there. So what's your plan?
All right, we're gonna cut that off, rebuild that, grinder smooth.
On both sides?
Yep.
All right, we got that hole fixed up. Mainly worried about the inside where that seal's riding back and forth on the chaffer frame. Make sure it's going to seal good and not get cut. So we got the inside all fixed. We didn't have to weld on this any. We actually, Josh took a big hammer on the inside and held it, and I smashed that back in on the outside, and we reshaped that a little bit, got it painted up. Same thing over here, got that hole fixed up, painted up. So as far as the damage on the inside of the combine, we've got that fixed. So I'm not exactly sure what actually caused this problem. It's kind of like when a rod goes out the side of an engine block and there's just carnage everywhere and you're not really sure what exactly happened. That's kind of what happened here. So I'm not sure what caused these sieve frame bolts to break, but it is what it is. I mean, I think it was a low hour failure. Maybe one of the bolts wasn't tightened good enough, or maybe the timing on the shoe system wasn't perfect and caused a bolt to break. I pulled the shoe drive shaft out that's turning the cams and the pitman arms to move the cleaning shoe. The shaft seems to be okay. Didn't seem like it's bent or twisted, but we're going to put a new one in it regardless. We're just starting over fresh. You know, we're going to make sure that this thing's 100% correct, because there's literally no room for error on a cleaning shoe. I mean, one bolt can break and cause tens of thousands of dollars in damage. So we want to make sure that this thing is right for the customer. So we're going to put a new shoe drive shaft in. We're going to put new cams on the drive shaft, new pitman bearings and arms. We're going to put all new swing arms and all new hardware on the machine. We're going to put a sieve frame kit on it. That part's not in yet, so we're going to have to do some other things until that part comes in. We'll rebuild the pitman arms, put new cams and bearings together. What else are we going to do? Yeah, so we're just going to try to do a bunch of little things to get that done out of the way. Once we get the frame kits in, I'll show you what we do to replace those side sheets. All right, so while we're waiting on parts, I want you guys to check out these new connectors that I got from Solder Stick. They are pretty cool, so check these out. All right, I got a new product that I'm going to try. Solder Stick sent me these connectors, and they're pretty cool. This is a 500-piece kit here, and comes with a little discount code if you want to order some more. Anyway, so this is a wiring connector, but you do not crimp this connector. So you slide the wires into this low temperature solder right here, and then you use a heat gun or a lighter or a little torch to melt the solder, which connects the wires together, and then the rest of the tube will heat shrink to the wire, which creates a waterproof connection, which works perfect for me today because the mice are at it again, boys, and they chewed through my wheel angle sensor harness, sorry. Yeah, so they chewed it through here on a 9670 combine, so thought it'd be a good time to try out these new connectors. So I got my little magnetic helping hands here. I got the wire strip back, and I'm going to use the red one to put these together. Now, this is the first time that I have used these, so we're going to figure out if I like these or not. So I'm going to use a red one, which is for 22 to 18 gauge wire here. This kit will go all the way from 10 gauge to 24 gauge, so fits a wide variety of wire sizes. So we're going to slide that into where the wire is right there. I'm going to use a Milwaukee heat gun, and we'll see what happens. Make sure I get it melted good. All right, let that cool. Well, isn't that nifty? So there you go. That's pretty strong too. Let's try it again. That solder melts pretty quick, so the solder melts faster than the tube does. So this is a new Milwaukee heat gun too. It's the first time I've used this. Okay, so we'll let that cool. Yeah, I did a little better job on that one. I'm getting better as I go. What I like about it, it's definitely a waterproof connection, which this harness is going to be underneath the combine its whole entire life. So, and I like that you don't have to actually crimp and smash the wires. Sometimes if you got small wires like this and you crimp it a little too hard with crimpers, it actually damages the wiring a little bit. So I'm actually liking these so far. It's pretty nice. And one thing I like about them as well is they're not as thick as you would normally have, like your regular heat shrink butt connectors. They're pretty thick, and if you have to do a bunch of them in the same spot, it will make the harness a lot bigger. You'll have a great big fat spot where you put all those connectors, and I don't think you're going to have that with these. So I kind of like that, especially if you got to, do a whole bunch of them in one spot. I think I could almost do a better job without these helping hands. So far, big fan of the solder stick connectors. I do not like these helping hands I got off of Amazon, but I am liking this new Milwaukee heat gun. That works pretty dang good. So see, if I had to put this in a harness in loom, I bet that takes up half the space it would have if I would have used normal heat shrink butt connectors. So that's something I haven't heard anybody talk about, these, is how much less space that they actually take up in the harness whenever you use these. So, all right, so I'm a firm believer in these, first time using them, and I really like these. So if you guys want to get you some of these, you can go to www.solderstick.com/sale and use the discount code ZK20 to get 20% off your purchase. So. And we're back, and we got parts. So this is a sieve frame kit here. So we're going to be putting new frame rails on the left and right side, put a new sheet, new channel up front, and new seals on the side. So let's get into that. Okay, so the first thing you want to do is do one side rail at a time, because if you pull both of them off, this thing just kind of falls into pieces and it's a real pain in the butt to put it on. So you want to do one side at a time. And we'll just take out all these bolts down the side, down here on this channel. We'll get all the bolts out, and then we'll just separate this frame rail. All right, so once you get enough bolts out on the bottom, you can take this seal plate out. And Josh is working on all the bolts that go through. There's a little cast piece in there. And there's 2 bolts inside of here that he's fighting. Right, yeah, that's where they were.
And then you have 4 that went
underneath.
Yep.
And then bolts all along the bottom. There was bolts all along the top. So I think we got them all. We just need to whack it and see what happens. So we'll give it a whack. She started to come out. Oh boy.
It's going. We're committed now.
I need a whack over here. A little tapper.
Yep. There it is.
There she be. Sweet. All right.
With our wavy wheel. She's a wavy.
Go on top of that or under?
That goes under that and in that.
All right, so we got that in and started everywhere. Now we're just gonna, we got all new hardware. The kit comes with new hardware, seals, everything, bolts. So we're gonna put all the bolts in loosely first, and we'll have to use an alignment punch to get everything lined up. Once everything's lined up, then we can start tightening it down. All right, so we get to try out my new Milwaukee M12 rivet gun here. We gotta basically build this piece right here. You got the order right yet, Josh?
I think so.
You think you're good?
I think so.
All right, first rivet this is ever done.
Send
Ready?
It. Send it. Oh, that's nice.
Whoa. Here, pull that out.
Real nice.
Feed me. I like didn't even try.
No.
Ready?
Yep. Done. Now you should be able to.
I thought it's supposed to go in the thingy.
It does.
It'll go in the next one.
Yeah, probably.
What's it look like on the back?
Perfect rivet.
Huh. Well, that beats the heck out of a hand
didn't
tool.
even try, man.
No.
Yeah, there you go. You shove the next one in, it'll push it.
It'll push it in.
Into your little.
Well, that's cool. Oh, it's in there. Yep, there it is. Well, isn't that nifty? And you got different bits that are underneath the battery here. And then it's got a tip tool right here that you can push out. And a light. Yeah. That worked pretty slick.
That was nice. Let's do it again.
I like it.
Let's do it again.
All right. Round 2. Not lined up.
It's got paint in the hole. That's the problem. There it goes. Send it.
All right. Huh. I heard it go in.
I heard it.
Ready?
Yep.
Well, it's just cheating, Josh. Just straight up cheating.
That's nice.
Yeah.
That's real nice.
All right, so we got all the bolts in it. I'm going to slam them all down except for these because I'm actually going to replace this channel because these rib nuts are damaged on here where that piece got ripped off. So, but I'm going to pull it off with that piece there. So I'm going to leave just a couple in here for alignment purposes, and we'll torque that down and then we can move on the other side. We got everything torqued down on this frame rail. Now we're going to put the seals on here. It goes like, where's the hole? Like that. Rivet that down, Josh. I need a second.
Oh, it had a little thing stuck on it.
Okay. Say, I heard it snap.
Yeah.
That's the snap.
Yep. That's it.
Awesome.
Woo.
Well, you already got it up there. You got 2 rivets. That one's pretty straightforward.
Put it in the hole. One-handed. Send it. And done.
Done.
Now the fun part
Yeah.
of getting over, under, yeah, everything.
Okay.
Yeah, that was a struggle, but
Now we can get all the bolts in. I'm putting blue Loctite on these. We don't want those to come off. There's really no reason this piece should ever have to come off.
no.
That's not coming off again. We got that side sheet all slammed down and tightened. Now it's time to use the awesome rivet gun. We just love using this thing.
Yep.
It's so much fun. Uh-huh. Ready?
Yeah.
Oh, if I can get it in the hole. Watch fingy.
Done. Done. Too easy.
Too easy. When you do those by hand, you got to give it some effort.
Oh, you do.
This is like nothing.
Done.
Too easy. Wham bam. Thank you,
Thank you,
ma'am. All right. Done. All right, since the sieve frame's done, we're gonna move on to the chaffer frame. I want to show you guys an improvement I've been making on these newer ones. You see this little piece of metal here? Well, since see this gap right here? Well, this will get plugged full of crop material in here and it'll bend out like this, all right? Which that'll pack full of stuff and that'll create a sharp metal edge and it'll cut through the sieve frame seal. I mean, it'll saw through it like a sawzall. So the sieve frame seal is sitting right on top of here. You can see where it was and it'll saw through right here and it'll just cut all the way through. So what I've been doing is I've been putting John Deere combine sealant up in here, and then I take a clamp and I smush it down and I glue this in to where it can't do this anymore. And then that keeps any material from building up in there and bringing that piece out so it's not jabbing and cutting into the sieve frame seal. So here's an example. This is the old sieve frame side sheet and look how it just cut through there like that. Right? So I've got this side glued down and clamped. So now that's perfectly flat and nothing can get in those holes or through underneath. Now check this other side out. It's a lot worse on this side where it was cut through that sieve frame seal. See how much that's bowed out? That gap right there. See how it's getting material wedged in there. So I need to get all that stuff out and push that back in. There's something stuck in there, but I'm gonna get that cleaned up and squeezed in and glued. I got the other side glued and clamped into place. So now I'm gonna put these little pieces on right here on both sides. See? Got a pretty good gouge right there and there. So the next thing I got done was put a new drive shaft for the shoe and bearings and hardware and flanges and everything. And we measured from the lock collar to the end of the shaft on both sides, wrote it on the side sheet. So lock collar to end of shaft was 3 15/16 on this side, and then we measured the other side, and then we'll get this lock collar on and get it the depth of the shaft just perfect. And I aligned the flanges with the paint line on the machine, because you can wiggle those up and down just a little bit. So that's done. I just got to set the depth, put the lock collars in, but I wanted to get that shaft in place because it's a lot easier to get to the bolts on the inside with no frames on the inside. So that's done. Had to put a new shoe adjustment harness. So these harnesses are going to the Chaffer and sieve actuators. The sieve frame came down and sawed through the wiring. So got a new one of those, ran into place, ready to rock. So the next thing I'm ready to do is throw that sieve frame back in there. Well, fill down some more. Tail up. All right. It's in there. Back up. All right, so we got the sieve frame set in there. I just used 2 straps and the boom on the forklift to lift that up. It's a little unbalanced, but it works pretty good. I just made sure that my seals weren't folded and they're in place. The hardest part is to get the seals up and over this cast piece here and going straight down. It's kind of tight in here, and plus with all new seals and sieve frame rails, it's pretty tight. All right, I like to get the sieve frame in here because it gives me a nice little area to lay on instead of all the augers and stuff. Now I'm going to take out this bolt right here. We'll take that swing arm out. That bolt, take that swing arm out, hang new ones in, hang new front sieve frame seals, or sieve frame swing arms in, sorry, and get those in the frame, get the back ones in place so that the sieve frame's hanging. A lot easier to lay in here with this sieve frame in place. Okay. Towards the rear. There. Right there. We'll line up that sieve frame. You just tell me up, down.
Okay, happy. Down.
Center bolt on the front chaffer.
Now it's good.
There it is. Talk to me. There it is. Pulling bolt.
Hold on. You didn't have it.
Okay. Up, a little forward.
Like that.
You got to get the nut just started before I push the bolts all the way through.
Oh,
Or else it's kind of hard to get it on there. Okay, I'm just gonna push it like just like that.
okay.
All right, that's the front. Now I just need to put the rear sieve arms on. Okay, Wardo.
Happy.
There.
Yeah, well.
I just had to hold my tongue just right.
Okay.
Yeah, they put the bolt in sideways. Let's see if it'll go in now.
The other new arms on top of the tire?
Yeah.
Okay.
Oh, it's in. That's so screwed up, I had to thread it out of the hole. Little burr bit on that old Milwaukee tool is the handiest thing ever.
Taiwan up, the man said.
Made in Taiwan up. Every swing arm like that is made in Taiwan up. Made in Taiwan showing, and it's at the top. Everyone. Talk to me.
I'd be interested. Oh. Right there.
Right there?
Right there.
So you don't want to stick your finger in there when somebody's impacting the other side.
No.
That little keyway that's welded on there will rip your finger off. All right, it's Chaffer frame time. It's coming in right now. Little right more. Steer left a little bit. With the rear seals. Push it back. 1 second.
Yeah, you did it.
Went in right now. We need to fix this sieve seal. Yeah, I know. We got to go in further first. In. Come up a little bit, Ward. All right, wow. In. Well, all right, hold on. I gotta go up in there and start those seals. I don't want to, but you kinda have to.
Can I lean on?
Have him come in some more. Come in a little bit. Whoa. Whoa. Down. Go down. Down. Hold up. Whoa. What's the deal? We hitting back here now? Shouldn't be. I'm gonna push it down.
Yeah.
There we go.
He's gonna have to go down some.
Go down a little, Ward.
Hold up.
Whoa.
You make sure you go down. Well, make it go down. All right, drop it.
Let her down, Lord.
Okay. Well, he's got this hooked up. I want to put the frame bolts through the front. How's that? There. It's in. That guy in a little hole. That guy in a little hole. Up how much? Take it in. Down a little bit. Yeah! All right, we got the Chaffer frame hanging, got new swing arms installed on the rear. So I went ahead and put new swing arms for the return pan in place. I'm gonna put the return pan on my little homemade jig on there. Don't laugh at it, it works. And we'll just be able to hoist that thing right up in there and put 4 bolts in the swing arms. Done. Poof, done. My jig works like a champ, doesn't it, Josh?
Yep.
Got the return pan in, swing arms, the bolts, everything. Now we're going to start the process of getting the pitman arms on, getting that shoe drive shaft set, make sure we got the depth correct. And once that's done, then we can start putting on the new pitman arms, bearings, cams, all that stuff. Then we can start the torquing and timing procedure. All right, I'm gonna put these on. So there are 4 different cams, 2 for the left, 2 for the right. The tapered end goes towards the shaft. Like that. And then I'll put the Chaffer arm here, and then I'll slide the other one on and put the sieve pitman arm there. Okay, so we got the pitman arms, bearings, flanges. These are the cams. So whenever this shaft turns, it makes this cam move, which makes this arm go back and forth. And then it attaches to the Chaffer swing arm and the sieve swing arm here. And it's like this on both sides, except the other side's got a drive pulley and belt to rotate the cleaning chute. All right, so Josh got the other side done. So this side's gonna have a little hub that you clamp onto the shaft with the pulley bolts to. So he got all that on and the belt tight. Now is the important part. I don't have any of the swing arm hardware tight. It's just finger tight. So that allows the bushings to be able to free spin. We're gonna roll this machine over 3 times and then we're gonna stop it in mid-stroke. So to turn the whole machine over, you just pull down on the chopper belt like that. It turns the whole machine over. See how these cams are rotating? So we're gonna do 3 rotations and then we're gonna stop it at mid-stroke.
And almost, a little more. about there.
Okay, that was an extreme arm workout. But when you are in mid-stroke is whenever this square is at 6 o'clock or 12 o'clock, and then your swing arms are in the mid-stroke position. All right, so the reason why it's so important to be locked in mid-stroke, because whenever you tighten this swing arm down, all these rubber bushings that are in the swing arms, they do not rotate, they twist. So you want to be in the midpoint so it can twist this way and then this way an equal amount. If you're off time, then that bushing is going to over twist one direction, which causes premature bushing failure, and it will cause a vibration. Okay, so now that we're in mid-stroke, we're going to start torquing, but I do it in a certain sequence. So we want to get these frames locked down to where these cams and these arms are going to be. So the first one I like to do is the pitman arm here. So when we torque that, that's going to lock this arm into where this pitman arm is supposed to be. And we'll do this one on both sides. And then we're going to do the pivot, the body mount bolt right here, and lock that down on both sides. Then we're going to lock the body mount one on the chaffer on both sides. And then we will do the frame. And then that will move the frame to exactly where this arm is going to be. And what that's going to do is it's going to center our bushings and our swing arms perfectly to mid-stroke in this arm. And once we get the chaffer, then we'll do the exact same procedure for the sieve. And then we'll do the return pan, the 4 bolts. We'll do these 2 bolts first. Then we'll lock the body for the return pan, and then the bottom swing arms here where it's going through there. And then it'll be done, and this thing ought to be smooth. And before we tighten any of these, I back these off, and we're going to put red Loctite on there. And then we're going to torque the 24 millimeter to 236, and then the 18 millimeters to 96 foot-pounds. But everything gets red Loctite. Doing it that way, you never have a bolt come loose, and I haven't had a bolt break after doing it exactly like this. So if you want no more problems with your swing arms and bolts breaking, do it just like this. So I use Loctite 277, and it works pretty good. So we'll put it on the threads, we'll torque them down all in sequence, and we'll be done. All of the swing arms are torqued to spec and Loctited down. So now we can move on to start throwing the elements in, so aka screens. So you got a sieve element goes in the sieve frame, then you got a chaffer element goes in the chaffer frame. Okay, so you guys probably noticed I put these plastic fingers on the back side of the pre-cleaner there. The customer had removed the raised chaffer extension, which bolts here, and then bolts where those fingers are bolted on. We pull those out because they just get clogged full of stems, and it creates a dam right there for grain not to flow through the screens like it's supposed to. So we've been pulling those out since we're on flat ground. We don't have a lot of hills, so we don't really need a lot of side hill stuff here. So I've been having good luck with taking the raised chaffer extension out of there. And then we basically are going to set up the chaffer exactly like an S670. So an S670 has these fingers, and then right now we're changing the partitions. So the original ones are green, and they're set farther back because the raised chaffer extension stopped here. So we're deleting that. So I'm putting on, gosh, these have got to go up to the front. You got to move this all the way up there. So we'll put these chaffer partitions up here like this, just on like an S670. So far I've had pretty good results. Customers say that it cleans way better and it doesn't get all fogged up. So that's what it's supposed to look like now. Just like that. Now we're gonna throw that sieve element in there. Sieve screen is in. Just got to put 4 bolts in it and torque them down, 26 foot-pounds. And then I'll bring the wiring up through here. It bolts there with a square grommet, bolts here, and then plugs into the actuator. And there you go. Chaffer is installed, and that's what it's going to look like when you convert it to an S670 style chaffer. All right, next step is to put the chaffer tailboard on right here, and then we'll get the grain loss monitors mounted on it. And then we got all this stuff to put on, the doors, the cob deflector door, and then we'll put the chopper and the PowerCast tailboard on. Chaffer tailboard is complete. Got the loss monitors and all the wiring where it needs to go. So now we can put these doors in place. You got like a plate that goes on, and then you got to put a cob deflector door in. Then we can put the chopper on. Doors are done. Got the trash tube on. You can get those from Sloan Express. That helps direct air across the tailboard, keeping your tailboard cleaner. And got the cob deflector door in as well. So now it's time to put the chopper on this thing. That guy right out there. So we got the chopper hoisted into place with the pallet and the forklift. Now we just got to get these big long side rails bolted on there to hold it in, and also the chopper actuators to hold it in place. Chopper is on. We got the PowerCast tailboard set up in there, and it just goes on with 2 pins, pin there, and then we hook these arms up into here, and then I'm going to hook the hydraulics back up to the control valve there, and Josh will get his wiring hooked up over there. And then I can tighten the belts on the chopper here. PowerCast tailboard is complete. Got the belts tightened up, and I made a 17-inch long 18mm socket to tighten those tensioners up for the chopper belts. Works really good. Now we just got to get some of the shields on. I'm going to leave some of the side shields off so we can run it without the shields on it. And yeah, get those on, and then we can take this thing outside. All right, here we go. Josh is going to open the grain tank up. Can't run the separator without the grain tank open. Well, the chopper's not in gear and it got mad. Okay, now it is. Try that. feels good to me. I like it. Let me give her a feel here. I know it feels good, man. I like it. Well, we got the combine all done. It runs good, runs smooth. Don't have any trouble, no codes or anything. No loud vibrations where we think something's going to explode. You know?
No, I think she's good to go.
I think she's going to live another day. We got this wounded soldier ready to go back to the battlefield.
Yeah.
So
yes,
that's going to do it for this video, guys. Until next time, keep that green iron moving.